For this lesson, we're going to start looking at graphing systems of equations. And systems of equations are formed by two linear equations, and there is one ordered pair that is a solution for both of these equations. So whatever we solve for x, that x is going to work for both of our equations, and whatever we solve for y, that's going to look. So they're going to have exactly one ordered pair that's going to work for both, and that ordered pair is going to be the solution. So we have a variety of different possible solutions. So our first that we have is that if a system has at least one solution, we're going to be looking at what's called a consistent solution. And so the graph of this consistent system intersects exactly at one point, or it's the same line. And on our next slide, I'm going to have some pictures that show you what these are like. So a consistent system that has exactly one solution is considered to be independent, and a consistent system that has infinite number of solutions is considered to be dependent. And this infinite number of solutions, these are actually the same line. So if I was to graph both of those solutions, that means that they would be laying right on top of each other. And then a system that has no solutions is called inconsistent, so our both line graphs are going to be parallel. So let's take a look at, we're going to draw our types of solutions, and we're going to put a picture with all of them. So here we have our number solutions up here. So this is if we were to have exactly one solution. And an exactly one solution means that our graph is considered to be consistent as well as independent. And the graph of these two lines is where there's exactly one solution. So both of the lines cross in exactly one point. And I'll put a dot exactly at that one point. So right there would be our solutions, right where those two lines cross each other. So then we have a number of solutions. We could have an infinite amount of solutions, which means that I would have consistent and dependent. And then the graph of these two lines would actually be laying exactly on top of each other. So there would be the first line, and then here's my second line. So as you can see, they're laying exactly on each other, so any ordered pair is going to be a solution. And then our last type is a no solution, and that would be considered inconsistent. And so the graph of those would be, as like our definition said, it would be two parallel lines. So we have a line here, and then we would have this line there. And so now here's a kind of our chart for our types of possible solutions. So we're going to graph each system and determine the number of solutions that it has. And if it has one solution, we're going to name it. So this name it right here is going to mean our ordered pair. So the first equation that I'm going to graph, I'm going to actually graph this in red. We have y equals negative 3x plus 10. So I know that I'm going to start at my y-intercept. So here's 10. So I'm going to put a dot there. And then I'm going to go down 3 over 1 because it's a negative solution, or it's a negative slope. And that's plenty, and so now I'm going to draw my line. And then my next line I'm going to put in blue. So I have y equals x minus 2. So minus 2 means I'm going to start at negative 2 because that's my y-intercept. And then I'm going to go up 1 over 1. And there's plenty of points. And so now I'm going to connect those dots. And at this point I need to see and look at my graph. So I see that right here at that ordered pair, the two lines are intersecting. So that ordered pair is considered to be 3, 1 as my solution. And so we have exactly one solution. And if I have exactly one solution, that means that it's a consistent and it's independent. And so that's my answer. So for this example, we have graph each solution and determine the number of solutions that it has. And if it has one solution, we need to name it. And when I look at my two lines that they have given me, I see that they're actually written in standard form. And I want to go ahead and put these in slope-intercept form because those are easier to graph. So to do that, I need to write them into y equals mx plus b. And so my first one, I'm going to subtract that 2x from both sides. So I'm going to get that negative y equals negative 2x minus 1, and then I'm going to just divide by that negative 1. So I'm going to get that y equals 2x plus 1. And then my other line is going to become y equals 2x minus 3. And so now I can go ahead and graph these. So for my first one, I'm going to start at negative 3. And I'm going to go up 2 over 1. And I'm going to keep doing that for all of these. And then my other line, I'm going to start at 1. And I'm going to go up 2 over 1 for those. And I can tell by my graph that I have two parallel lines. And so since they don't ever cross, my solution is no solution because there's not an intersection point. And so therefore they're inconsistent. I could also say that I don't even have to graph these because right here I notice that they both have the exact same slope. And so if you notice that relationship between them, you can go ahead and automatically say that you have no solution and it's inconsistent. So go ahead and try this one on your own. We're going to graph each system and determine whether the number of solutions it has, and if it has one solution, go ahead and name that solution for me. So the first thing that you should have done is you should have rewrote your equations to put them into slope-intercept form. And the first one, we're going to get that we have y equals positive x, actually, minus 2. And then my second one will become y equals negative 2/3 x plus 3. So now I can go ahead and graph these, and I'm going to start with that second one. So I have my 3, and then I have down 2 over 3. And I'm just going to put one other point up here. And now I can connect those. And then for my next one, I'm going to get that we have, I'm going to start at negative 2. And then I'm just going to go up 1 over 1. And so I can see that my intersection point is right here. And that intersection is 3, 1 again. And so therefore we have a consistent and it's independent. Joe and Josh each want to buy a video game. Joe has $14 and saves $10 a week, and Josh saves or has $26 and saves $7 a week. And how many weeks will they have the exact same amount? So we're going to actually graph these equations. And so my first equation, I need to figure out something. So we have that Joe saves this $14 a week, or $10 a week and $14. So I'm going to have that Y equals, and so $10 a week, so that $10 that first week, that means he has another $10 the second week. So if I was to look at the amount of money, I have that $10 times his weeks. And he already has that $14 originally, so I'm going to add that 14 because that's my constant. I already started at 14, and then I'm going to keep adding that $10 a week. And then we have that Josh has $26, and he's going to save $7 a week. So I have my $7 a week plus that original 26 that I have. So we're actually going to draw our coordinate plane. And since I have both my y-intercepts are positive, I'm just going to draw the first quadrant. So I'm going to actually go up by 2's. So this first dash is 2, 4, 6. And then we'll go by 2's there too. So my first line, I'm going to go start at 14. And then I have to go up 10. So, and then over 1. So that's going to be my first line. And then my second line, I have at 26. And we're actually going to go up 7. Over 1. So they're going to be right about there. Or I had to fix my line because I went over 1 wrong. And on your graph, your line should be intersecting up here. Unfortunately, my graph, I'm not able to draw that completely out. However, our solution is going to be so that at 4 weeks, their money will be the same.